Good morning, everyone. Welcome to day 4 of EAMS 2020. We've got some very interesting talks lined up for you today. I'll bring up the programme. Hope everyone's well. We're having a heat wave in the United Kingdom at the moment, so very hot here. This morning we have two longer talks. So one from Karen Henderson at the University of West of England, Bristol, about using e-assessment to provide some targeted online maths support. And that'll be followed by a live talk by Björn Ruffer on fast, efficient static randomization via Sage Math generators and decorators. Just looking ahead to this afternoon, we've then got three lightning talks at 4 o'clock British Summer Time this afternoon. Just a reminder that if possible, if you have questions for the speakers, if I could ask you to place these in our Moodle site in the questions section for the session this morning. So the reason for this is that the speakers continue to answer these after the session is finished, so that conversation can go on. Okay, so without further ado, we are going to run a pre-record of Karen Henderson's talk. Karen is with us this morning, so at the end of this talk, she'll be able to take some questions that you might have. So this is Karen Henderson from UE Bristol talking about using e-assessment to provide targeted online maths support.
Hello, I'm Karen Henderson, and the title of my talk is Using e-assessment to provide targeted online mathematics support. I'm an Associate Professor in Technology Enhanced Learning in the Department of Engineering, Design and Mathematics at the University of the West of England in Bristol, and I'm also a mathematician. So this work was funded by UE's pedagogic scheme and ran in the 2018-19 academic year. It was a collaboration between the Learning Innovation Unit and 2 departments of the Faculty of Environment and Technology. Rhys Gwyntlew led the project, and the other team members are listed on the slide. Rhys Gwyntlew, Emily Walsh, myself, and Kevin Golden are all mathematicians working in the Department of Engineering, Design and Mathematics. Oliver Haslam is from the Learning Innovation Unit, and Patrick O'Flynn and Danny Elvidge are both from the Department of Architecture and the Built Environment. I should stress that although I'm giving this talk, others have done far more work on the project than me. So the plan of my talk is as follows. Firstly, I'll give you some background of the problem we wanted to address and how we went about planning the resource. Then I'll give you a demonstration of the resource and an overview of it, and finally finish with a discussion and our plans for future work. So despite Mathematics A-level being the most popular subject taken, this qualification is not a requirement to study many quantitative courses in higher education. For example, courses such as computer science, business studies, environmental science, all require some mathematical background, but at UE and elsewhere in the UK, Maths A-level is not an entry requirement. Many such courses include some top-up maths content, but some students will enter university without having studied mathematics since GCSEs, so that's at age 16, and can find this daunting. Research shows that lack of confidence is one of the main reasons that students find the transition to higher education difficult, so the focus of our project was how to address this skills and confidence gap. And what we've done is to develop a diagnostic tool and online resource with the aim of providing support for non-mathematics students, by which I mean students who are coming onto courses which do not require Mathematics A-level. So I'm not talking about students coming onto a maths degree or onto an engineering degree. It's onto courses where there's some maths content, but it's not the primary focus. And by allowing applicants access to the resource once they've confirmed their place on the course, our aim is to increase the mathematical ability and awareness of students prior to starting at university. So this would benefit students in that they would be confident about applying to UE and feel more supported in their transition to university and start their course with a stronger mathematical base. Our first steps were to carry out an investigation into the mathematical requirements of students from the courses across all the faculties at UE. The user logs from Espresso Maths, which is the university-wide mathematics support drop-by station, pinpointed which courses and the specific areas of mathematics in which students currently require extra support. And 2 courses were identified to be in the pilot study, namely foundation students on BSc Architecture and Health Science Apprenticeships. Danny Elvidge, who's on the project team, is heavily involved with the architecture course, so that was an obvious choice. And we can see that science was the biggest user of Espresso Maths for maths, as opposed to statistics questions. And after discussions with academics in that faculty, the Health Science Apprenticeship cohort was suggested as a suitable course. This course has entry points throughout the year and isn't just a September start. For each of these courses, a list of key mathematical topics were identified. So from now on, I'm just going to focus on the Health Science Apprenticeship route. So for this programme, we identified 4 key topics, and within these topics, we identified subtopics. So the 4 key topics identified were algebra, graphs, numbers, and data. And then, for example, within the topic of graphs, we identified 2 subtopics, namely plot and interpret straight line graphs and graphs involving distance, speed, and acceleration. So the learning resource that we've created is web-based and has intelligent branching, which provides decision trees to navigate the student through the resource. Hopefully you'll see what we mean by intelligent branching when I give you a demonstration. The DOIS e-assessment system is used as the primary diagnostic tool, which then signposts the user to further online learning materials as required. So let me tell you a little bit more about DOIS. It's an algorithmic e-assessment system, which was developed in-house and was first used for summative assessments in 2007. It's now widely used in the university, particularly in the business school and in all 4 departments of the Faculty of Environment and Technology. It supports random parameters, and you can use a lot of different question types, such as numeric, algebraic, multiple choice, multiple response, as well as marking computer code. It has lossless data collection, which means that information on every assessment attempt by every single student attempt is stored. It's got student-friendly features built into it, such as pre-submission checks and network down recovery. And being server-based, it's able to interact with other packages, such as Xerti, which is what we've used in this project. In constructing the resource, referring back to the previous page, we listed topics and subtopics, and for each subtopic, we identified key skills associated with it. So, for example, the subtopic of simplifying algebraic expressions, which sits in the topic of algebra, 2 key skills were identified, namely simplifying linear expressions and simplifying non-linear expressions. For each of these key skills, a Xerti learning resource has been created, which I'll show you when we look at the resource itself. So now what I want to do is to give you a demonstration of the resource so I can show you some of the features. So this is the front page of the resource for Health Science Apprenticeships. First thing to show you is that there are 3 different access options. You can access anonymously, pseudo-anonymously, in which case you would set up your own username password, or by embedding the resource within your university's VLE. At UE, we use Blackboard. If the latter 2 options are selected, then the system records the student's performance and keeps track of where they've got to within the resource. So this means that you can return to the resource at a later date and pick up where you left it. But if accessing pseudo-anonymously, then we as academics won't know who the student is, just which course they're on. So the first 2 options going in anonymously or pseudo-anonymously would be suitable for pre-registered students, so students who haven't yet started at university, so don't have university logins yet. But the latter option, so embedding within a VLE, would be more suitable for registered students. And in this example, I've chosen to enter the resource anonymously, so I've been allocated a username of guest. So in this case, our progress, or my progress, will be stored only for the duration of the session. Once the browser's been shut down, then all the data for the sessions will be discarded. Coming down, we can see the 4 mathematical topics in the blue blocks. And clicking on these topics, the subtopics appear. Icons to the right of each subtopic enable a student to track their progress through the resource. So the green semicircle indicates that I've accessed but not completed that subtopic. And the green ticks show that the activities associated with that particular subtopic have been successfully completed. Also, if you click on the eye to the right of each topic, then brief additional information about what is involved in each topic, as well as why it's important for your course, is revealed. Now, each subtopic is a link which takes the student to a short e-assessment. So what I'm going to do now is I'm going to click on this subtopic, which is that of plot and interpret straight line graphs. So by starting a new test, it's going to take me to an e-assessment, which is going to gauge my understanding of that particular subject. And this in turn will enable the system to guide me to further resources on that particular subtopic, depending on my performance. So in this case, 2 questions have been presented involving plotting and interpreting straight line graphs. So I'm going to try and answer the second one correctly. So I want the value for the gradient and the value for the y-intercept, but I'm going to deliberately answer the first question incorrectly. So I don't know, let's put 5.678. Now note, this is an example of a pre-submission check. The question asked us to present the answer to 2 decimal places, but we've had a warning that we've entered our answer to 3 decimal places, but actually only 2 were required. So let me fix that up. Doesn't mean the question I'm going to have answered it correctly, but I have now answered it to 2 decimal places. And the other thing to state is that because DOIS is algorithmic, each time a student enters the test, students are presented with different realizations of the question. On submitting answers, then the submission is automatically marked and we're presented with a report detailing how we did on the test in the summary page. Note that no marks are presented here, just statements as to whether the question has been answered correctly or incorrectly. And this non-disclosure of marks is a deliberate feature of the resource, and the DOIS architecture had to be amended to accommodate this. We wanted to avoid the potentially demoting effect of students receiving low scores. I'll now show you what is shown by each of these buttons within the summary section. So clicking on feedback, we get a fully worked solution for the questions that were presented. So we see the question that had been presented, a fully worked solution, and the report that we saw on the previous page. For question 2, again, here is the question that the student was presented with, here's the fully worked solution, and here's the report. Clicking on the next button along, which is what you did well, gives us access to this page. Remember that I answered the second question correctly, but not the first. So in this case, the subtopic is split into 2 key skills. Those being to be able to obtain the gradient and y-intercept from the equation of a straight line, and to be able to obtain the gradient of a line passing through 2 points. And for the e-assessment presented here, it just happens to be partitioned such that each question assesses just one of these skills. However, it is possible to have more than one question testing the same skill, for one question to assess more than one skill. So by answering the second question correctly, I've been identified as being able to obtain the gradient and y-intercept from the equation for a straight line. I've got the option of viewing additional resources, which is a Xerti learning resource. And some students may want to access all the material, but the website that we've created has been designed to target the areas that a particular student needs additional help with. So it's not necessary for students to click on and access that. Clicking on the next button along, which is what you need help on, we get directed to this page. So because I got the first question wrong, and this was identified with the key skill of obtaining the gradient of a line passing through 2 points, I've been directed to view a learning resource associated with this key skill. Note we have a visual symbol together with text indicating that I haven't yet viewed the resource. I'm now going to click on this learning resource and let's see what it looks like. So this is an example of a Xerti learning resource, and one of these pages was created for every key skill identified. So each Xerti learning resource is a web browser tool containing partition regions that can interact with the user and each other. Each of the regions contain a learning resource, such as, for example, instructional videos, e-assessments, various or otherwise, text and images. Typically, on accessing the Xerti learning resource, students are directed to first watch a video, which is playing in this top left-hand corner. Key points can be indicated in the commentary area, which is this right-hand box of the page, and breakpoints can be inserted into the video in order to add emphasis. Finally, having watched the video, students may practice the mathematical subject that they've just learnt about by testing themselves using the assessment, which appears in this bottom left-hand page. And I should stress that the project focused on collating material as opposed to generation. So the videos here are ones which we have found in the public domain, so typically they're YouTube videos, and for the test yourself, we tended to use e-assessment questions that were already created. So let me just play this for. Okay, enough of that. And at times we'll have breakpoints here, which will pause the video, will highlight key points, so a commentary can come up here. So the idea was that students are watching this material almost with a tutor over their shoulder, pointing out the important points. So trying some practice questions, then in this case, there's only one practice question, but there could have been more. And we can try this as many times as we want, and this isn't recorded. And students can try over and over again until they feel they've mastered that subject. And students are directed to, at the end of their practice attempts, to go back to the summary to try the test again. So let's go back to the summary. So now you can see that the visual symbol has changed, and the text has changed, so we can see that we have now viewed this learning resource. Once students have accessed the learning resource, they're recommended to have another attempt at the assessment. In fact, they could have done this prior to accessing additional help. So the summary page sits as a tab in the resource, and so the try again button is always available. On clicking this, another DEWIS assessment opens up, but with different parameters as before. Note that because when I tried this assessment previously, I answered the second question correctly, you'll see that there are green smiley faces next to the input boxes associated with this question. Clicking on these automatically populates the answers. The reason for including this feature is to allow students to concentrate on the questions that they need help with. Of course, they could answer those questions themselves if they so wish. So what I want to do now is I want to get the question correct. So I'm just going to use my calculator to work out what the gradient of this line is. So having just done this question on my calculator, I think the answer is minus 1.43. And now I'm going to submit my answers. So happily I got that one correct. But having answered all of the questions correctly, then I will have successfully completed this subtopic. So if I go back to topic home, we can see that I've successfully completed the topic of plot and interpret straight line graphs within graphs. I can still access my summary. I could still have another go if I wanted. And if I come back to home, then we can see I've now got a green tick against that subtopic. Once students have successfully completed every subtopic, then they will have successfully worked through all the material in this resource, in which case they're going to get awarded a completion certificate. Other things to note, we have tried to design the resource so that it's got a clear interface which allows easy navigation with consistent icons to allow students to track their progress. Okay, I think that's all I wanted to show you within the resource. Let me come back now to the PowerPoint, and I'll finish up by talking about a bit of implementation and evaluation. In terms of implementation and evaluation, some of the Xerti learning resources were trialled on Architecture's Foundation students in November last year. Danny Elvidge, who teaches these students, created his own videos, walking students through some of the trickier topics. He received many positive comments from students, and I've just included one quote here, which hopefully you can read from the screen. Also, the complete resource was made available to a group of health science apprenticeships in late January this year. In terms of next steps, now that the DOIS Xerti structure is in place, it's relatively easy to create further resources. So to create something similar for another course, we would need to determine what topics, subtopics, key skills are relevant, and to identify suitable YouTube videos and existing assessment questions. So it's more of a case of collating resources as opposed to generating new material. With only minor changes, it will be suitable for use for our foundation engineers, and we plan to make it available to students once the A-level results have been released and the students have unconditional firm offers. Those students can be sent a copy of this in order for them to prepare themselves in a structured way before coming onto the course at UE. And we're also going to look at setting something similar up for our first year students, pitching it at more sort of AS plus level maths. And I think that's going to be especially useful this year because of the disruption due to COVID. It'll be a useful activity for them to do during induction and the first few weeks of the semester. So finally, if you want to explore the resource yourself, then please just click on the link shown on this slide, and I'm happy to take any questions. Thank you.
Okay, thank you very much, Karen, for an excellent talk. I think we've all got some ideas there for how we're going to soundtrack our maths videos in the coming year. I have a question for you on math support before I. So if participants would like to direct some questions to the Moodle questions area for this session, I had a question to start off with about the math support side of it. So in your topic there, in your subject area of health science, the topics that came up were largely GCSE, I'd say. We had similar experiences at Newcastle, looking across many sort of non-maths engineering subjects. Did you find that? Did you find that as well in the other subject areas that you were looking at?
Yes, I think there's going to be quite a lot of commonality in the topics that we've picked, because of course, if they don't need Maths A level to come onto a course, all they will have done is GCSE. So I think for subjects definitely at UE which don't need the maths, then it's going to be the last math they might have done would have been GCSE. So we're just trying to refresh and get them to that standard again. Because of course they won't be particularly confident having not covered it for a couple of years.
Yeah, absolutely. You've had similar experiences that it's not necessarily the grade at A level, for example, but actually just having continued to do maths and not have that gap. Very interesting. So there's a question from Christian asking, is there some server-side setup to start using Xerte, or is it in the cloud? Was it already in use at UE?
So Xerte is definitely something that UE is using. Now, of course, how you interface Xerte with Dewis, that was definitely a Fries Gwynthew thing. And Oliver Haslam, who's part of the Learning Innovation Unit. Fries is somewhere, whether he can type something or help me out here, Fries. It's like talking to students, isn't it?
Yeah.
I've asked Reese to unmute himself.
Oh, it's installed in UE, I've heard. Shouting up the stairs.
Okay, thank you. So a question from James Fody. It appears that you need to first identify weak points for a specific course, then you can start developing. How long and how many developers were needed for you to have the first version released?
Well, I think to get the setup, it was Rhys Gwynthew and Oliver Haslam put like all of the work together in getting that structure together. So now that structure of how Dewis interfaces with Xerte is set up, it's relatively easy now just to set up a Xerte page and to plug it into the resource. So how long? Well, we probably were only given a total of half a day per week for a year for one person to set this up, but I think it probably actually took more than that. But now it's in place. I'm hoping that once you identify the topics, subtopics, key skills, it's just a case of identifying decent videos, and pretty much nearly all e-assessment stuff's already created. And for the test yourself part, not the original diagnostic, you could use other e-assessments that could just plug in.
Thank you, Karen. A question from John McDermott about these little green smile icons. The idea
yes.
that you've already answered a question correctly. So John asks, in order to pass each subtopic, how many questions must typically be answered correctly? So if you have many questions for a subtopic, is there must a student answer them all or some percentage correctly?
I think they have to answer them all correctly. So of course, once they've answered one key skill correctly, then they'll get those, they'll get the green smiley faces. So it's sort of, it's incremental, because this is stuff they've done. This is what they absolutely need to, it's quite basic stuff that they need to be able to do to progress, really. Of course, if they can't get through it, then we would be able to put on extra classes.
Okay, thank you very much, Karen. There are a couple more questions on the Moodle site, so I'll leave that to you if that's okay.
No problem.
It's 9:30, so I think we'll move on to our second speaker. So thank you again, Karen. And I'm going to pass over to Björn, who's going to talk to us now live. Just okay, all yours.
Hey. Yeah, let me just share my screen, just a second. Okay, so I hope you can see nothing, which is an empty screen. And now you should see the title of the slide, or the talk, which is Fast and Efficient Static Randomization via SageMath, Generators and Decorators. So welcome to my talk. I'm an academic at the University of Newcastle, Australia, not to be confused with Newcastle University, United Kingdom. So I'm here at 6:30 p.m. and I'm still in my office. So what I use basically is SageMath as a computer algebra system. It comes with these Jupyter notebooks. I'm going to show them in a moment. I use these to generate static assessment items, and that feeds in particular into paper assessments and into Blackboard online assessments, but other output formats are of course imaginable. And the approach that I use here is essentially agnostic to the output format that you want, and it supports LaTeX. So let me just show you what the output format looks like. So this is, I hope you can see a PDF file that I'm sharing here right now. So what you see here is a PDF document, and this is being printed. In Newcastle, we have these so-called whiteboard workshops. We have engineering and science math service lectures that are taken by 500-ish students, and we break them up into smaller groups, and they have workshop groups, and they meet on a weekly basis, and in the workshop they work on problems together in front of whiteboards, and at the end of each session there is a quiz, and that enforces essentially attendance. And this is an example quiz from 2 years ago. So there are multiple choice questions in this one, two of them, and there's also some written answer questions. The format doesn't really matter. What needs to matter is that there are, because of the 500 students, and we have multiple workshops during each week, so with maybe up to 30 students in a workshop, so there's quite a number of these workshops, and they're not all at the same time. And so the questions can't really be the same in all these workshops, so you need randomization. And so all these questions are randomized. There's shuffling between the answers, and there's also different versions of these questions where the numbers are really different. And the same with written answer questions. And I have another example. Okay, so this is the student view of the Blackboard side. I'm just beginning a test here. I've completed this test. Oh, that's too bad. I think I have one that I haven't completed. Or that I can reattempt. Let's try 10. Yes, I can start a new submission. So this is, again, some multiple choice questions. The setup is similar to before. Because this is online, multiple choice seemed to be the easiest way forward, and we just do multiple choice and no written answer questions in Blackboard. And Blackboard has some disadvantages in terms of authoring questions. So that's why I use SageMath to develop everything within my computer algebra system, basically, where everything has a very nice workflow. And of course, what I would like to see is questions that basically look like the questions that I'm posing the students. And I want them typeset nicely. And this is, of course, LaTeX, so you can see that I can select things here. And so these questions need to be generated somehow with random variance. And in Blackboard, what you can do is you can upload basically a table with questions of multiple choice questions, and that is called a pool. And a question pool then becomes one of these questions. So you might have 10 or 100 or more versions of each question. And these question pools, so each question pool becomes one individual question, and this quiz here has 5 questions. And so you need 5 of these pools, and creating them by hand is of course a very tedious task, and hence automation to the rescue. And then I'm also using the same format in basically generate text files where the mathematics is LaTeX formatted. I use that for a blind student, and the blind student has a screen reader, and the student is able to listen to the text file basically, and because it's LaTeX, then expressions like /int and so on make sense, and the student understands what that means and can do the computations and answer in the text file. So that's a really good workflow for integrating someone with a vision impairment. So coming back to This is an example file. Also, maybe I should show this. So this is what just a recent quiz that I generated. So the semester is just over here. This is basically what this looks like when I author quizzes. Let me just start executing these cells. This is a Jupyter notebook. This is, if you haven't seen this before, this is free. This is comes with SageMath. It's built on Python, on top of Python. This looks a bit complicated maybe, but what's happening here is I'm executing the cell here. The cell defines a function, and there is a decorator here. I'm going to explain that all in more detail. And then at the end, what you see here is some preview of all the questions being generated. And you see something Q colon, and then there's some question text, and then there's answers being shown here. The correct answer is denoted by C, and the wrong ones by D for distractor. And that, yeah, so there's quite a few of them. Of course, that's not really helpful if you want to preview the question and really check that something is correct or incorrect. So if you scroll down further, I actually have a LaTeX preview also embedded in here, similar to the quizzes that you saw in print. So, and the same, so this is the preview that I see in my notebook, and the same thing generates also a file called, let's see, what is it called? It's called quiz10.tech or something, or .csv or tsv or whatever you define your output to be. So this, actually this is the folder. The file name is actually the name of the function, and that this output generation all happens automatically, and the magic really sits in this line here. And this entire thing here is called a generator, and a generator is different from a function by having this yield statement instead of a return statement. And having shown already a little too much here, I'm coming back to my presentation. And now this is sort of a tutorial. I just walk you through a little bit how this looks like and how you could create something very similar for your own workflow in generating static assessments. And yeah, so the idea is not that I actually show you my code that I use, but I just show you how the ideas basically fit together. So first I'm going to talk a bit about lists and generator expressions, and then a bit about generating different types of previews and outputs, and then I talk about generators, which have to do with generator expressions, but sort of a standalone feature themselves, and about decorators. So lists probably exist in many programming languages. In Python, they look more or less like this. They can contain any sort of content. It doesn't have to be all numbers or all text, can be mixed. And in Python, or in Jupyter, which is this notebook format for Python, you have this display command that the same exists within SageMath, because SageMath is built on top of Python. And so you can print this list of lists quite nicely here, and that is what it looks like. And the display command looks at interpretations of D. Everything in Python is an object, and D can choose to return a text representation, but it can also choose to return a HTML or LaTeX representation. There's also a notion of sets. That's all not so important. Generator expressions, on the other hand, are important. So this is what a generator expression looks like. It looks similar to a set or a list or a tuple, and it has embedded a for loop, basically for x in this case, in this tuple here, we create x squared, and what we get out of that is this list here. So this is a very concise way to write a for loop, and that's a generator expression. The next thing is not a generator expression. This is the essence of the format that I keep my questions in. So my questions are basically lists, because I have different versions. There's one entry per version, and the first entry of or each entry really is again a list, and the first entry is a question, and the next entry is the correct answer, or even a set of answers, and the first one by convention is always the correct one. And then I have a bunch more of these, and I can then choose later to combine the correct answers of the other questions and use them as distractors for the first question, for example. And that can all happen automatically, and you can automate all these things. So what you really need to concentrate on then is only really creating items that look like this, okay? And that can, for example, then be formatted in this way using, say, a generator expression where you pose everything here in a sentence. So you have these substitution features here. This is called a formatted string or F string, denoted by this F in front of the quotes here. And we're looping over a list of tuples that have two tuples, and you can deconstruct them in Python using this notation here. But that's all elementary Python. If you know a little bit about Python, you've seen that before. If you start learning Python, this is among the first things you see. Now, there's also a notion of writing functions, and I can use this function here to format nicely my answers. So I have a set of answers, so I just choose to take all the answers that I had in this set on this list here. So that I extract the 6, the 7, the 5, the 3, basically all in here, and that ends up in the set of answers, and that's happening in this expression. And then I pass this down here, actually, I pass this into this function, the set, and I also pass what the correct answer is supposed to be. And then what this little code here does is it prints in a text representation of all the answers, numbered A, B, C, D, E, and it marks the correct one with an asterisk. And you could, of course, imagine that you return two versions, one that you print or that you submit to a student or show a student, and one for yourself that you use for marking purposes. Yeah, we can then look at this also together with a question and generate strings. Here you have a string representation. If you print that, it looks a little nicer. Actually, it's not printed, it's split at the new line symbols. Once you have a text representation of your question, that's sort of a dead end. It's not that useful to have for further processing. So this is now, as you notice, not LaTeX formatted. This is just text, but maybe I want a nice HTML representation. Maybe I want a nice LaTeX representation. Then once I have this is a little, well, not as useful. I can sort of deconstruct that again, but that's a very tedious thing. So it's actually better to keep things in the original format, which was this, and that's sort of the most useful format that you can convert into many other different things. So for example, I can take the questions I have and I can store them in a table. So this is a very short Pythonic way of creating a table, and it looks quite nice. So here's the question in the first column, then the answers come in the next columns. They wouldn't have to include A, B, C, D, I guess. And the last one is always none of the others. By the way, that's a design feature for multiple choice questions to always have this fail-safe answer. In case you stuff up, then there is the question itself not completely wrong. All you have to do is change the marking and say the correct answer was the last one, E. So that's by design. But usually the correct answer is not E. And then once you have this table, you can very quickly, just with one line, save that into a file. You can even make this a file that Blackboard can understand. Blackboard doesn't use comma-separated files for their question pools. It uses tab-separated files. Tab is the sort of multiple spaces almost. And this is what the file looks like. So that's all specific to one particular output. The Blackboard input format is slightly different, but it's documented in the on the Blackboard site itself. And so it looks very similar to this actually. So easy to get there from here. Yeah, we can do more exciting stuff. We can create mathematics because we are in a fully fledged computer algebra system with SageMath. So here I'm generating a random polynomial. I'm not going to go into the details. It doesn't look very fancy here, but I can make it look more fancy by using this show command. And the show command basically asks the object P for everything in Python is an object for different representations that it has, and in this case for a LaTeX representation. And if it has a LaTeX representation, then it shows the representation here, and it looks nice. And then I can do stuff with my polynomial. I can differentiate it, for example, and all that happens within SageMath. And I can, of course, use that for my calculus course and create assessment items very easily. Now, LaTeX in previewing, there's a bit of a trick if you want to typeset with LaTeX longer expressions, so paragraphs of text that contain a formula. By itself, SageMath supports formulas, but it doesn't really support paragraph type LaTeX, and this is a bit of a workaround. It's a little technical, but it's not very long, as you can see. It's in the slides that you find on the Moodle site, so you can copy it from there and expand it from there if you want. And what you should really look at is the documentation of the display command or of the show command, and that contains hints what you need to do to create different representations of strings. Here's just an example how you would use that in the display command. So I have created a string. This is the string. It's a raw string. That's hence the R here. That ensures that these backslash here is not interpreted to denote special characters, just as an ordinary backslash. And this is some HTML in here. And embedded into the HTML is actually LaTeX formula. And you see it looks like this. And actually this looks a little terrible. But I can switch to, not this one, where is it? The other one. Oh, must have been this one. Actually, yeah, so here's the notebook that generated my slides. And as you can see in the notebook, the representation is actually much nicer. It actually looks as you would expect. Here's a display representation of this formula. And if you look back at the this description here, it actually includes this little bit of JavaScript here. This loads what is called MathJax, which is a JavaScript engine to typeset LaTeX in the browser. So that's something to work around deficiencies of Blackboard in particular. So here we are. With that, yeah, we can also look at string representations of the same thing. So the MathJax basically provides a representation that includes MathJax. That's what this construction does. Right, and then you can also get LaTeX representation of any SageMath expression, any mathematical expression. So we had this polynomial. If I evaluate the polynomial at the variable x itself, and then evaluate that, then I get the LaTeX code. And I can use that for typesetting of questions. Okay, so much about the representation. Let's talk generators. So generator expressions, I showed this one here before. The other one, the two also appeared previously in the talk. What you haven't seen yet is this one here. It's sort of the same construct, and we are not looping over a list of some expressions. So A was a list here, or tuple. This one here was a list, I think. This one here is a generator, range 10. Range 10 produces the numbers from 0 to 9. And if I range over those and evaluate this expression, I get this thing here. And generators are basically things like this range function or range generator, and we are now building our own. So we are building one that can generate questions. And here it is, it's quite short. And it's basically like a function, but a function usually ends with a return statement. A function can also have arguments. My generators for now don't have arguments, but you can make them more fancy if you want. And instead of a return statement, what a generator usually does or could do is contain some sort of loop. It could be an infinite loop, but I advise against that. And in each loop iteration, it produces an output. So that's like returning many, many times for every iteration of the loop. And I strongly advise to build a safety net, something like this, into your question generator. Doesn't have to limit the number of outputs to 10, but maybe 100 or something. That saves you from ending up in infinite loops. So what's happening here is I think we may see some output later. If I just call my this function, so it's like defined like a function, it actually returns something, and what it returns is a generator object. And how I use that is in a generator expression. So I can say for Q in this generator expression, notice the invocation of this function here, and then I get a list with 10 prototypical questions here. So there's a product. The question is, what is a certain product? The correct answer by convention is the first answer, and then there's 3 distractors. Okay, so this could feed into my output routines to create various types of quizzes, online or paper-based. And then of course we needed formatter. So let's go simple here. We already had this formatter, this MCA function that I showed earlier, and we can use that and some string formatting in this generator expression here. This is just a very simple way to do this. And then it spits out nicely formatted questions. These /n's here actually denote the line breaks. And so you have the questions nicely formatted, and you have line breaks in there, and you could adapt that to your own purposes, of course. So this is a formatter, and here is if we print the formatted strings, then it actually looks nice. And we could then use that, for example, for the blind student. This would be perfectly adequate if I could just take this output and send that to the student. Now let's put this all into a function, and the output routine that is. So the output routine takes a question list and just prints out the output nicely, and I think it limits it to just the first two items in this list. And the list could also be a generator, I think. Or maybe not. Okay, decorators. So decorators are these things that I mentioned earlier. So we have this function here, the function or the generator that produces the questions, and that's nice in itself, but we want to have a preview, and we don't want to call the preview function every time. So what we do is we add this thing here with the add notation, and if I just add this inconspicuous little thing here in front of the generator definition, then every time I execute the cell, this happens, and I see the output. And you saw in what I showed earlier, you can even have LaTeX output in there. So it can look really fancy. And this thing is called a decorator, and now the question is, how does a decorator work? This is the decorator I just showed you. It's a really short thing. The important bit is it is a function that takes a function, and it returns a function, and in between it can do something to the function. It could change it, it could wrap it into something else, or it could also just use the function. In our case, it uses the generator and takes a few samples from it, and then just returns the original generator thing itself. It can just be called like normal afterwards. So this is sort of a transparent layer that you add to the generator, and what that does is exactly the print mechanism. So when you define this this function here, this generator, what this decorator does is it takes one instance of this guy, takes two samples from it, and produces nice output for them, and then just leaves the decorator defined like it would be if this expression wasn't there. So then you have these guys here, for example, all defined in some separate file that you just include in your Jupyter notebooks. And in your Jupyter notebooks, all you really do is for every quiz or assessment item, you just have a bunch of definitions of generators that generate these the question variants that you care about. And everything else can happen in the decorator. Setting this as the output to a file, generating the preview, and all of that, and it's all automated then. And of course, you have to tailor that to your own purposes because you probably use something else as a backend than I do. Okay, I think that's essentially that. Let's recap. So I'm a big fan of static assessments because of the use of print assessments that we used to have here in Newcastle until the pandemic. Now it's online, and because Blackboard is quite efficient, it's actually easier to generate these static assessment items and upload them to Blackboard than to fiddle with Blackboard's more advanced features of how do you call those, the questions that have variables and code and stuff like that embedded. That's not very nice in Blackboard. And so the keys are generators and of course also decorators. And I would also like to mention there is a tool that I use for generating these paper-based assessments. It's called Math4X, and that's sort of a sister presentation which also lives on my homepage. And you find the link in the presentation for this presentation at the very end, if in case you're interested in that. And that's all. Thank you.
Okay, Björn, thank you. I don't know if you want to stop sharing your screen there.
Yeah, that's a good idea, probably. Stop, yeah.
Thank you very much. So again, if I can ask people to pop questions in the Moodle questions area. So one from James Fodey here asking about the interaction with Blackboard or say Moodle. Asking, is all you need a Jupyter notebook or something else besides SageMath being interpreters? The way I understood this was that you export something like a XML type file that you can import to Blackboard. Is that correct?
Yeah, so I generate questions basically as lists, as I mentioned, and I then have code that converts them usually in the same session. I don't really store these lists. I just convert the output of these generators directly into a format that I can use. So for Blackboard, that is this tab separated value format, which is basically a table like a spreadsheet. The first column, I think, says MC for multiple choice. Then comes the question field, and then comes the first answer, and then comes a field that says correct or incorrect, and then comes the next answer, and then comes the field that says correct or incorrect, and so on. And that's the format for multiple choice questions. I haven't really looked at all the other different formats that you could have for different Blackboard question types. I know they have like 20 different question types. And for print, I basically generate files that contain a nicely formatted LaTeX code that is then included into an exam file or something of the sort.
So these questions, they get imported to some sort of question bank in Blackboard that you can then pick from. Is that how that works?
Yeah, I can actually, maybe I can even show that. Let me just exit the preview here. And maybe reshare my screen if where is it? Yep. Oh, this one. Share. So I'm now in the in my Blackboard site for the course I've been teaching here. So 500 something student, a calculus course, and I'm going to this course tools, and in here is is this test surveys and pools, and I can create pools, and you see quite a lot of them here. Some have quite a big number of versions. When I started this, so this all started during the pandemic, right? So we were in the middle of the semester is now over, and the learning curve has been quite steep. In the beginning, I was quite eager, and because I created many versions, random versions, and it turns out that's not necessarily a good thing. In case there's a single mistake somewhere, then you have suddenly 300 versions where you need to fix that. So maybe keep it down to 10 in the beginning for the first iteration. Anyway, what you can do is you can import a pool file, and there's the thing here, so I can import a pool file here. Might have to go to Math 1110, there it is, assessments, and then I have, say, quiz 8, doesn't really matter. I have it has to be a text file. The text file, you might maybe see the preview here, is of this tab separated value type, but Blackboard expects the ending .txt. I open that, I give it a name. No, I just do that. I thought I had to give a name somewhere. No, that's not what I want. Sorry. I haven't done this in 2 weeks, and now it's already, okay. So what I do is I don't import a pool, I build a pool, I give it a name, just call it EAMS 2020 or something, so that I can later find it again. Then I submit that. I don't put anything in here. So the trick with Blackboard is never put anything into any fields unless you really have to. And then you say upload questions, and there you browse and pick that file. So here you see, for example, I have a text file and a txt file for each question, because I also have the print output. I don't add any marks at this stage. I do that later when I assemble the quizzes. And now this file has, it seems, 5 different versions. And you can try to preview in here, but it doesn't look very nice. But it's all LaTeX code, and it's the randomization also happens within the code that does the exporting into a text file. So not always is the first answer the correct one. I shuffle that in the SageMath code, because if I didn't, I would have to do this in Blackboard, and there's an option where you can say shuffle the answers, but you have to go into every single version manually and click that box and then save, and it's so tedious. And also, I always want the none of the answers option as the last one. So, so these versions are all really different in terms of the formulas, I think. But the answers are also shuffled, right? So that's how that works. Once I have this, I can create questions or quizzes or assessment items, and then I can then take these pools, and each pool turns out to be a single question. And at that stage, I add the marks per question and so on. I can go through that if you like.
No, I think I think we're out of time actually, Ben. But thank you very much. That clears up, I think, how it integrates with Blackboard. There's some interesting questions on the Moodle site there. We'll have to call it the morning there. But if you want to head on over to continue the conversation over on in the question section, that would be great. If I can just pull up the program for this afternoon before we go. So this afternoon we have 3 lightning talks. One coming back to some of the issues that we faced with the pandemic around exams, and then 2 further lightning talks looking at web work, for which there's a developer update tomorrow actually. So I hope to see a lot of you at the talks this afternoon, and have a good day everyone. Thank you.